you draw n times at random with replacement from a box of numbered tickets, the standard error of the sum is like the square root of n times the SD of the box. The standard error of the mean, sample mean, is like the SD of the box divided by the square root of n. Okay. It follows from this, and we're not going to do the proof here, that if you look at the difference between the sample mean of n draws and the average on the numbers in the box, the probability that those differ from each other by very much gets really, really small. The probability that they're very close together gets closer and closer to 100% as the sample size grows. So the sample mean is sort of a more and more accurate estimate, more and more reliable estimate of the mean of the box, the average of the box, as the sample size grows. Yes?
Can you just look sample mean? It's just a constant, just a number, right?
The sample mean, it depends on the sample. It's
And then sample mean is just a single number. So when you take standard error of a single number, isn't it just always going to be sample mean itself?
the sample mean depends on what sample you get, right? So I could draw from the I could draw from Okay, so here we're looking at the sample mean. This is the same box we had before, the numbers 1, 2, 3, 4, right? I'm taking a sample of size 5. You can't quite see it. Sample of size 5. So that time the sample mean was equal to 2. That time the sample mean was a little under 2.5. That time the sample mean was 1.25. Right? Sample mean isn't always equal to the same thing. Right? It has a probability distribution because it depends on what sample you actually get. So it's a random variable. Okay? The mean of the box is just a number. Okay, but the sample mean is a random variable. It depends on which random sample you get. If we do this over and over and over again, then the empirical frequency with which we get each possible value of the sample mean is going to tend to get closer and closer and closer to the probability that the sample mean takes that value. And so the average of the values that I get of the sample mean is going to tend to get closer and closer to the average of the box. The expected value of the sample mean and the average of the box in this case are the same. Okay, the SD of these values that I got in all these trials, 10,000 samples of size 5, was 0.63. The standard error is almost exactly that. The standard error of this SC, the mean, is going to be the SD of the box divided by the square root of 5, the sample size. Okay, SD of the box is 1.41, square root of 5. Okay, all right, so that's where this number comes from. And empirically, we see that the spread in the values of the sample mean that we actually got in 10,000 replications of this experiment is very, very close to its theoretical value of the standard error.